got going on there. So our observed difference is minus 60.
But it would be 6, never mind, because technically the difference is
Yeah.
You won't do that though, you won't put like 60 and negative 60, will you?
Yeah, not for that one.
Okay.
So for that one, no. But if it was one sample, I think it's okay. I can put a negative version.
Why are you not putting the negative?
It's technically the difference.
Because the group labels are technically arbitrary, okay, for two groups, okay. For one sample things, for the test statistic, I might put a negative one, and that would actually be difference, reveal making a true mistake. Yeah.
Are there going to be things on last semester on time?
What?
No,
from before the midterm? Yeah, so we'll talk about, I have a few questions at the end of this test that are questions from before the midterm, and we'll go over those, and I'll give a few example type other things. Pick your brain. Okay, so what's our resulting test statistic? Okay, so it's always observed minus what's in the null divided by the standard error. So we got the observed difference, right? Our observed difference is minus 60, and the null difference is what? 0, okay, right? In the null hypothesis we got 0. And what's our standard error? Okay, so if we forgot, we can always look at the study guide and say, oh, for two sample means, the standard error is square root of S1 squared over N1 plus S2 squared over N2, okay? So make sure you use the right answers. 110 squared over 30 plus 130 squared over 25. And so when you do this, you get 32.85. Alright, so our test statistic is our observed difference, minus 60, minus the null over our standard error, 32.85. And we get a test statistic of negative 1.826. Okay, so how many degrees of freedom do we have? So that's answered in number 30. For 31, we've got to look this up in which table? The T table. And how many degrees of freedom do we have? N minus 1. So we use the smaller n. We do 25 minus 1, and I have 24 degrees of freedom. 24 degrees of freedom. Okay. Again, our T table doesn't have any negative signs, so we're just going to ignore this negative sign and look in the T table to see where this lies, okay? And we see that when we look at the row for 24 degrees of freedom, I've got 1.318, 1.711, 2.064, and I'm looking for 1.826. So 1.826 is in between here and here. And do I have a one-sided or two-sided test? One-sided test. One-sided test. So I'm using the one-tail probabilities, which are 0.05 and 0.025. So what's my p-value? Yeah, my p-value is less than 0.05, but bigger than 0.025. I don't know exactly what it is, but I do know it's between here and here. Okay?
And you forget the negative in test statistic when...
Yeah, when you go into the T table, just ignore the negative signs, okay? And just look for the...
What's your T table temperature?
Sure. Okay. All right. So this is my p-value. It's between 0.025 and 0.05. Okay. And Sarah, I think you had this question. You know, what do we do if I said, so for 32 it says, what conclusion do you make and my alpha is equal to 0.05, right? And my p-value is between 0.025 and 0.05. So is my p-value bigger than alpha, less than alpha? What is it? It's less, okay? So even though 0.05 is my boundary, I know my p-value is less than that. So my p-value, whatever it is, I do know it's less than 0.05. And that means it's less than alpha, which means what? I reject the null hypothesis. I reject the null hypothesis. Okay. Alright, if our previous conclusion was wrong, so if 32, if the conclusion we made in 32 was wrong, what kind of mistake is that? That's a type 1 error because we've rejected the null. So if rejecting the null was wrong, that's a type 1 error. Okay? What does it mean to commit a type 2 error?
When you accept the null.
Okay? But in the context of this problem, when we're talking about caffeinated drinks, what does a type 2 error mean?
That we said that the times are equal.
Yeah,
No,
so
that liquids are equal.
We reject that it's
Except for that
better time.
hypothesis when it's wrong.
okay, so let me just write this down, okay? Alright, so what does type 2 mean for this problem? It means, in reality, so the truth is that caffeine does make a difference. But we do not make that conclusion, okay? We do not believe that it does. Okay. And what does a type 1 mean? In the context of this problem, a type 1 error means caffeine does not make a difference, but we believe that it does, okay? So here in caffeine, the null hypothesis is true, which means caffeine does not make a difference.
And that
That's the null hypothesis is true, but we reject it. So we believe that it does make a difference. So that's a type 1 error in the context of this problem, okay? So there might be something like that where you've got to make a practical interpretation of what it means to make a type 1 error or a type 2 error. Alright, that's 28 through 33. Yay? Okay. So we'll keep going. Alright. Let's look at 34. In a certain city, a study was conducted to see if the police department had a different proportion of minority employees than the fire department. Okay? They randomly selected 200 employees from both the police and fire departments and took note of whether the employee was a minority or not. So of the 200 random police department employees, 80 of them were minorities. Of the 200 random fire department employees, 50 of them were minorities. Is this evidence that the two departments have different proportions of minorities? Okay? So 34 says, for a hypothesis test, write the appropriate hypotheses. Okay? So here, are we dealing with one sample or two samples, and are we dealing with means or proportions?
Sample proportion.
Two sample proportions. Okay. So what is the null hypothesis and what's the alternative hypothesis?
P1 minus P2 is equal to 0.
P1 minus P2 equals 0 is my null hypothesis. And the alternative, it says, is there evidence that the two departments have different proportions? So, not equal to 0, okay? Because we're just asking, are they different? We're not saying, is this one department more or less or something. We're just asking, is there a difference in proportions?
So that's a two-tailed.
It would be a two-tailed test.
Do we have any graphs on the test?
No. For this hypothesis test, what's the value of p hat? Okay, so p hat's total number of successes divided by total observations. So we had 80 people who are minorities in the police department plus 50 people who are minorities in the fire department divided by a total of 200 plus 200, 400 people, okay? So my p hat here, 0.325. What's our test statistic? Okay, so here we got to do, observed minus null divided by the standard error. What is my observed difference? Yeah, P1 hat minus P2 hat. So P1 is 80 over 200 or 0.4, and P2 hat is 50 over 200, which is 0.25. So I have 0.40 minus 0.25, giving me a difference of 0.15. In the null hypothesis, we have 0, and my standard error is some crazy number. This thing, 0.325. P hat times 1 minus P hat divided by 1 over N1 plus 1 over N2.
So it's similar to the last set of questions earlier.
Exactly.
Probably exactly the same.
Hmm?
Probably exactly the same as far as like the method for two samples.
Yeah, in terms of the method, it's the same. It's just a matter of reading the problem and recognizing that this is the same type of problem. Okay? So my test statistic is going to be 0.15 minus 0 over that thing, 0.04684, and I get a z-score of 3.20. So that's my test statistic. So what do I do with my p-value? How do I get that? I look it up in the z-table, okay? So if I look up positive 3.2, what will the z-table give me? It's going to give me like 0.99 something, right? Is that what I want to double? No, I want to double what's the area in the tail.
1 minus 1.
I got to do 1 minus that, okay? So I can either look up the positive value or the negative value, right? So if I look up z equals 3.20, that's going to give me 0.9993 or something like that, okay? This is not what I want to double. I've got to find the area in the tail. This is area that's not the tail, okay? So the tail is equal to 1 minus 0.9993, which gives me 0.0007. And now I double that. So my p-value is double that.
Well, when it's a two-tailed test, don't you take the negative anyway?
Yeah, you can, okay? So you can look up 3.2, or because it's a two-tailed test, you can just look up negative 3.2. And if you look up z equals negative 3.2, you're gonna get 0.0007 straight up
So
on the table.
basically, if you start as a
Let me
positive
throw it
z,
back.
Yeah.
then you have to subtract it by 1, but if you start as a negative z, then you just keep the number.
Yeah.
That's it?
It's whatever you're used to.
Yes.
So always use the negative.
Okay. Yeah, if you're doing a two-tailed test, look it up in the negative side and double it. Okay, is that what I say?
You mentioned that in the study hall.
I was doing it the other way and getting the same answer, so I'm
No,
confident.
it just says find the area of one tail and multiply by 2, okay? So you can take the negative 3.2 and find 0.0007 and double it, or if you're not comfortable with that, look up positive 3.2, subtract from 1, and then double that, okay? Just don't double 0.9993, okay? And if you ever get a p-value that's bigger than 1,
Then you know it's wrong.
stop, and you know you did something wrong, okay? But a wrong answer choice will be, 2 times 0.9993, which is going to be like 19984 or something like that, okay? 86, okay? This will be a wrong answer choice that's available to you, but you've got to know that a p-value should never, ever, ever be bigger than 1, okay? P-value is never bigger than 1. Never bigger than 1. Okay, because a p-value is a probability. Probability is never bigger than 1.
When it's a two test, when it's a two test, you subtract from 1?
It depends. Okay, if you look up the positive value, you got to subtract from 1 and double it.
I mean, but when it's a two-tailed.
Yeah.
Yeah, but then if but you can also look up the negative value and straight up double it.
understand
So.
that, but when it's a two-tailed, you could look up the negative value or the positive and minus 1.
Yes,
Like that.
either way.
Question.
Yeah.
There's only 2 times when we're subtracted by 1. If it's either greater than, or if the,
Yes.
the statistic comes out to positive.
Right. Okay. All right. Perform a hypothesis test. What is the conclusion you make? So this is 37. This is my p-value. Okay. This is the p-value for 37.
Very low.
All right. Very small. So 38. My p-value. It doesn't even specify alpha, but I do know it's going to be less than alpha. Okay. Even if alpha was 1%, this number is smaller than that.
Yeah.
So p-value is less than alpha, so I reject
No.
the null hypothesis, okay? What does it mean to commit a type 1 error?
Reject the no when the no is correct.
Okay, so type 1 means we rejected the null when H0 is true, okay, when the null was true. Alright, so what does that mean in the context here? It means fire departments and police departments what? Fire department and police department.
Do not have a difference.
No, it means, according to the null hypothesis, the null hypothesis is true. So it means that fire department, police department either have no difference or have the same proportion. Have the same proportion of minority employees. But we incorrectly believe that there is a difference, that they are different.
Wait, so I just want to make sure if it's two-tailed, like for, I guess the problem number 37, we multiply the p-value by 2, right?
You multiply the tail area by 2 to get
Oh,
your
yeah.
p-value. Okay.
Oh, yeah, if
Yes.
it's two sample.
Not if
two
it's two
tail.
sample, it's two tail.
Okay.
Two tail.
Because you could have a 2 sample means, but it may
Only.
not have the equal to, it could be greater than or less than.
Okay.
So 2 samples just determines the formulas you're going to use for the standard error. But here, we double this by 2 because the hypothesis says it's a two-tailed hypothesis.
Oh, okay, because it said 1 minus 0.9993, so
Uh-huh.
I figured that. Okay, I just mistaken that.
This is the tail area, and I'm doubling the tail area because it's a two-tailed test.
Okay.
Okay. So that's so this is what it means to commit a type 1 error. Is that all right with everyone?
Yeah.
Okay. We're almost there. Almost there. All right. 40 through 44. Let's try that. Okay. Potatoes are sold at the grocery store in 5-pound bags. And you decide to weigh a random selection of 10 bags, and you find that the average weight of these bags is 5.2 pounds with a standard deviation of 0.3. Is this evidence that the grocery store has a mean weight different from 5 pounds? Alright, okay. So we're going to do this with a 95% confidence interval. Alright, do we have one sample or 2 samples, and are we dealing with means or proportions?
Means, one sample.
One sample and its means. Okay, so I can just look straight at the study guide and see how we make confidence intervals, okay? And it says we're going to make a 95% confidence interval. So how many degrees of freedom do I have? 9. N minus 1. 9 degrees of freedom. Okay, what's the center of the interval? Okay,
X bar.
X bar. X bar is our center, so 5.2. And what is the standard error? So the standard error is going to be S over the square root of n. So 0.3 divided by the square root of 10, 0.094. 949. 0.095. Okay? Alright, so let's make a confidence interval, 43. So using 9 degrees of freedom and 95% confidence, my T star is going to be 2.262, right? So I have 5.2 plus or minus 2.262 times 0.0949.
Why is it analytic like 9 4, not +0?
You probably made a mistake. Try 0.3 divided by the square root of 10. Did I mess that up? I think you did 3 divided by the square root of 10.
Oh yeah. Sorry.
Okay. So when you do this, you get 4.985 to 5.415. Okay, so is this evidence? What conclusion do we make? Is this evidence that the bags at the grocery store have a mean weight different from 5 pounds?
Fall within the range.
So 5 is within my interval. So what does that mean?
There's not a.
Yeah, 5 is in the interval. So we do not have evidence that the mean weight is different from 5. So that's 44.
X bar plus or minus 1.
x bar plus or minus the critical value times the standard error. All confidence intervals.
Professor,
Yeah.
what is the conclusion for type 1 and type 2 errors? Do we say we believe or we incorrectly believe?
We just say we believe, okay? We never know if we believe correctly or believe incorrectly, okay?
Because it said, we said we incorrectly believe.
That's when we're asking what does it mean to make a type 1 error.
But not for type 2.
Yeah, I know. Type 2. Whenever we make a type 1 error, type 2 error, we incorrectly believe the wrong thing, okay?
Okay.
Okay? That's why it's an error.
So we only said we incorrectly believe.
If we're talking about an error.
Yeah.
If we're talking about an error. But whenever we make conclusions just in general, we just say we believe, because we don't know if we're right or wrong. We're hoping we're right. Every time we make a conclusion, we hope we made the right conclusion, but we don't know until someone says, nope, you made a mistake. And we're like, ah. Alright. Last page, okay? It hasn't been too bad, right?
No.
We didn't get started till after 7. It's only 9:15. We're about to finish up here, okay? So,
Good information.
huh?
Good information.
Alright, a fair die should land showing the number 4 1/6 of the time. You roll a die 100 times and you count how many times it lands as the number 4. And it lands as the number 4 20 times. Is this evidence that the proportion it lands 4 is different from 1/6? Okay?
One sample proportion.
Alright, so, yeah, 1 sample or 2 samples? 1 sample. And we're dealing with proportions, okay?
Are we back to the old material or not?
Huh?
Still.
This is still all,
List.
still all new chapters, 8 and 9, 7, 8, and 9. Alright, what are the appropriate hypotheses here?
P is equal to 0.1667.
Okay, so the null is that P is equal to 1/6, or P equals 0.1667, and the alternative is that what?
It is not equal to.
P does not equal 1/6, okay? And what is our sample proportion, number 46?
0.2.
P hat is 20 over 100, okay? We're getting 0.2. So it's landing on the number for 1/5 of the time. Alright? Is this a problem? Yeah,
Is
Lisa.
there another option to choose instead of 1/6?
You can write P equals, the null hypothesis would be that P equals 0.1667. Alright, but I prefer the fraction form for this one. 1/6. Yeah, 1/6.
Yeah. I prefer this.
You prefer the
I like
decimal?
the decimal too.
Alright, well,
Hard luck.
we'll see. Okay, of course the problem's not gonna be exactly the same, so we'll see what happens on the
Why
end.
not? We pretend we don't know.
Yeah, then it becomes, then it would not be stats XL10, it would
Right.
become memorizing practice test XL10,
Exactly.
you know?
It would actually be how to make a computer class, how to minimize all the answers on the whole day.
Yeah. Cheat sheet making, XL10. Yeah, that's not good, okay? It's hard writing a good test, trying to write a test that says, do you understand statistics? What does that even mean? That's a hard question. Okay. When performing a hypothesis test, what's the standard deviation of your sampling distribution? Okay? So this is a weird way of saying basically what's the standard error? Okay? What's the standard error? That's what 47 is asking. What's the standard error? So anytime you see what's the standard deviation of the sampling distribution, that means what is the standard error? Okay?
Yes.
Always, even with me.
Well, I mean,
Yeah, even with means, if I say what's the standard deviation of the sampling distribution, that means what is the standard error? That is,
sampling distribution standard error.
the standard deviation of the sampling distribution is